So hello everyone. Today we are going to see this question, that is minimum limit of balls in a bag. So in this question you are initially given a array nums where ith bag contain nums I ball, and you are also given a max operation variable. What do you mean by a operation? Definition of a operation is given here. Like you can take any bag balls and you can divide it into two new bags. Let's take in a bag you have five balls, so you can divide it into 1, 4, 2, 3, similar fashion. And then down you are given your definition of a penalty. A penalty is maximum number of balls in a bag is defined as penalty, and you wanted to minimize your penalty after the operations. So let's take an example to understand it better. So let's take you are given some initial bags and bags have some balls. So let us understand with example, like first test case, that is you are given 9 and number of operations is 3. So you can take like initially bag has 9 balls, so you can divide this 9 into two fashions, that is 4 5, then 6 3, 7 2, 8 1. Similarly you can divide it, so you have to you can divide it at most 3 times. Basically you can divide this 9 into 4 5, then you can divide this 4 into two parts, that is 2 2, or any fashion whatever you like. You have to do this operations minimum like three, maximum 3 times only. Like this is one operation, this is one operation, this is one operation. So like after this operation our array is 2 2 3 2, so minimum is 2, so you need to minimize this penalty basically. So basically this is what is our question is able to tell us. Now coming on to the example test case, that is 9 and 2. So for 9, they are initially splitting it into 6 3, and then this 6 is divided into 3 3 C. So like the minimum possible value from this array is 3. So answer is 3. And then we have the second test case, that is 2 4 8 2. So initially we are dividing this 8 into 4 and 4, and then we are dividing another 4 into 4 and 4, and similarly like we have three operations left, to like this four, all fours are divided into 2 2 2 2 2, similar fashion, and the whole array is 2 converted to 2, and so our answer is 2. So like after seeing this approach, first thing which strikes into my mind is as like we are just distributing, like we the number of balls are limited. Like let's take initially, like whatever we have balls in this array. Let's take this example, 2 4 2 4 8 2. After finishing, after distribution, the number remains same. So can't we evenly distribute it? Simply distribute it and divide it by number of bags of it. Like I thought of it like we can generate a formula, that is summation of all balls in the bag divided by total number of bags after all operations. This was my formula, but as we see, like in my test case, like let's say 9 and 2 which were given, like our bag is 9, bag array is 9 and operations is 2. So like total number of is 2 and 2. Like in one operation basically we are adding another bag. Like let's initially we had bag, we distributed into 2, so there is just an addition of bag. So we can write this formula as summation of all upon n plus number of operations. So it will lead out to 9 divided by 2 plus initial size was 1, so 9 divided by 3, so answer turn out to be 3, which is our given output. But this test case eventually fails out when, let's take another example, that is 7 and 17, and let's take our operation is 2. So like according to our formula, what we will do, we would take this bags are is 7 and 17 and operation is 2. So according to our formula, we will take 7 plus 17 and operations are 2, and whatever is the initial size is 2. So we would take that as 24 upon 4, that is 6. So 6 would be the answer according to the formula. But let's take a deeper dive. Like what according to question, we will take initially 17. 17 can be divided optimally into 8 and 9 only. Otherwise, the value would be more. Like 17 can also be divided into different things like 7 and 10. But this factor is 10, which is larger. So it would lead out to complications. So like for optimality, basically a greedy approach, we are taking this only 7 and 9, 8 and 9. And then as we have one operation still left, so we can reduce this into 4 and 5. So like our final array would be 8 4 5 7. But according to the questions, like answer should be 8 and our formula is giving 6, which is wrong. So I thought of a heap-based approach. After this, like initially I implemented this. That is like I was just accumulating the number of array and then dividing it into number of size plus operation. But this was wrong for the test case, as I mentioned, 2 comma 17 and operation would be 2, so it gave me a wrong answer on that. So after thinking a lot, like came up with a greedy approach which I mentioned, like a number x can be divided into two things, that is x by 2 and x by 2. And if a number is odd, this is for even number. If the number is odd, so it can be divided into x plus 1 by 2 and x by 2. Let's take an example, that is 3 can be divided into 2 and 1, or 5 can be divided into 3 or 2, and if the number is even, that is 4 can be divided into 2. This would be a greedy based approach, so thought of applying basically it. So in this, the problem was I was going to iterate to apply all operations, but the limit of operations in 10e9. So it would eventually lead to TLE, but I still implemented it and tried it. It gave me the TLE basically. Like I was initially populating my PQ with all the numbers in my nums array. Then I was doing all the operations. Initially, I was just taking the maximum element, then pushing basically k by 2 and k by 2, that even odd logic. And then I was popping and just calculating it after this operation. So like this was my implementation for this even odd, and then I was just doing this operation number of times, and I was just returning the maximum value after all the operations are given. So let's take example, that is 2482, which was given. So initially I would pick 8, divide 8 into 4 and 4. So my after PQ of like for operation 1, after operation 1, my priority queue would contain 2 4 4 4 2. Then it will pick 1 4, then would divide that 4 into 2 2, then 4 4 2, and number of operations would be like, let's take, like in this question we were given as 4. So basically like our bag is 2 4 8 2 and our operations are 4. So like initially my PQ would contain all the elements, that is 2 4 8 2. Then it would pick the maximum element, like by PQ dot top it will get it, divide this into 4 and 4. Then my PQ would contain this array, that is 2 comma 4 comma 4 comma 4 comma 2. This is one operation is lost, operation is equal to 3 here. After applying operation 4, we would get 2 2 2 4 4 2. So operation is equal to 2 here. After this would be applied on this and then this. So finally array would be 2 2 2 2 2, and my PQ dot dot would also contain 2, so it would all give a right answer. But due to the constraints of the question, like we were given a constraint of 10e9, so this would be a KLE. So after looking at the constraint, my mind struck on two things. That is, first was constraint for 10e9. So we need an optimal approach like constraints for 10e9. So we would lead a log n approach, something similar to that of log n or O of 1 using some formula. And one more thing was, question was of a type maximize the minimum. So like these two factors struck me to go through a binary search approach. Like these two are a many very famous patterns of binary search approach. So I thought of just checking for binary search on the space of basically for finding the answer. Like it is a very famous concept, that is to search the the space for the answer. Basically, what do I mean by it? So like my answer could be possible, like whatever my answer would be, range into something like, let's take the minimum element in the nums to the maximum element. My answer wouldn't exceed that. So I would iterate through all possible values in this range using binary search. So what would I mean by this is, for the given example, let's say BG is equal to 9 and our operations were 2. So I would search, my search space for the binary search would be L would be 1 and my R would be max of like the whole BG array. So it is 9. So I would search from 1 to 9 on the basis of some certain condition. So like what would be the condition? Like we in the question we are given some operations. So we would calculate how much number of operations would this array be needed in order to transform such that minimum value is x. Like it would be difficult to understand like this way. It is better to see code. What am I saying? One second. So this is my code. Like initially, like the minimum value is 1. Then I'm taking the max value from the array. Then this is basic boiler template like L less than R. Then this is for the shifting part, and this is basically else if. This is the main function helper which will determine the number of operations required in it. So how I am doing is basically is like this. You were given like initially I'm keeping a count whatever would be my count of this count of basically operations in order to transform it. My formula for getting the number of operations for ith character is basically ceil of c by x. What where x is what x is basically the middle element. Let's take example like 2 4 8 2, and we were given some operations. So let's take our middle value, basically like the middle is l plus r. Like in order to avoid basically the long integer value, I've taken l plus r minus l by 2. You can also write it as l plus r by 2. It doesn't matter. It's just my boiler template code. Basically, in order to find the operations, I'm using this formula that is c by number of middle. Basically, whatever is the number of operation, minimum number of. Let's take two. Let's take my example is 3. I'm assuming that my answer would be 3. So I would divide 2 by 3. So no operation needed for it. For 4, 4 by 3 would eventually give me 1. For 8 by 3, it would give me 2. Similarly, in order to determine, I am determining number of operation for the ith character, and on the basis of that, if it exceeds my like the whole number, like basically max allowed operations, then I am returning false, otherwise returning true, and it would lead to a monotonic search phase. Monotonic is basically like it would give me true, 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 and then false, 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 or like false, 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 and true, true, true. It couldn't be like true, false, true, false. This is not allowed in this. Otherwise, binary search would not work. So, in order to determine this, I have used this template. And in order to get a clean code, like this was my actual code which I've submitted. Basically, like the as I explained, like this is setting of the limits. Then this is the boiler template for the binary search, and you can also write here L plus R by 2. This doesn't matter. And then I have this helper function in order to determine whether it is possible to make that number or not, and this is my operations in order to do that. That is this operations and formula. Thank you for this video.